Okay, a function is not differentiable at points of discontinuity. At points of discontinuity. What does that mean? What do you mean by that? How can we prove that if a function is not continuous, is discontinuous, if a function is discontinuous, this means for sure it's not differentiable. How can we prove that? If they ask us to prove this, first, for sure, we have to know that limit of f of a plus h as h tends to 0 is the same as limit of f of x as x tends to a. Why? Because if the same, substitute instead of xa here, so it will be limit of f of a, and this will be equal to f of a because h tends to 0. So same thing here. And not only that, limit of f of a plus h as h tends to 0 minus, it's the same like limit of f of x as x tends to a minus, because it will be f of a minus, and here will be f of a minus. Why? Because it's f of a plus h, which is a little bit below 0. Yani 0, this means it's 0 minus. So f of a minus equal f of a minus. And for sure, the limit of f of a plus h as h tends to 0 plus is the same as limit of f of x as x tends to a plus. These three very important notes we should know. And this means the limit it do exist. Now, suppose we have a function defined at x equal a and it is not continuous at x equal a. Suppose that f of x is not continuous. It is defined and not continuous at x equal a. So it is defined but not continuous at x equal a. What does that mean? Limit, suppose that f of x is not continuous. So limit of f of x as x tends to a does not equal f of a because it is not continuous. This means instead of limit of f of x as x tends to a, we can take limit, instead of limit of f of x as x tends to a, we can use limit of f of a plus h, limit of f of a plus h as h tends to 0 does not equal f of a. And how is that can be written? We can say also the limit of f of a plus h as h tends to 0 minus f of a, right? We take the f of a to this side minus f of a, so it's not equal to 0. Sorry, f of a is a number, so we can insert it inside the same limit, right? Now, we do what in this case? We continue by doing what? By dividing by h. And why we are doing this? Let's see. Limit of f of a plus h minus f of a over h as h tends to 0, is equal to what? Since h is 0, so the numerator is 0, right? And since f of a plus h minus f of a, we have it here it's not zero, so it's non-zero number. It's non-zero number. Okay, what do we have as an answer if we divide a non-zero number over zero? The answer for sure is going to be infinity. And what does that mean? This means the derivative does not exist. This means this limit here does not exist. And this limit means what? Means the derivative, right? It's the definition of derivative. So the derivative does not exist. Not exist, because the answer is infinity. What's the meaning of derivative not exist? This means it's not differentiable. So we started with not continuous, and we ended with we don't have derivative not exist, means it's not differentiable. Okay, and for sure we can do the same thing as x tends to a plus and as x tends to a minus, where we can change it to as h tends to 0 plus, h tends to 0 minus, the same thing exactly. So this is the proof of a function. If it is not continuous, a function, if it is not differentiable, sorry, if it is not continuous, then it is not differentiable. So the function is not differentiable at points of discontinuity, means if it is discontinuous, if it is not continuous, this means for sure it will not be differentiable, because we don't have a point to have derivative on it.